That's so stupid. Sorry. Yeah, so this is the hot word for a while. Get used to it. So do you guys know what probability is?
50.
Well, I mean, that's an example of what we call like, yeah, and odds and probability are not the same. If you were to like watch, you know, the newscast or something, people would try to convince you that they are. At some point, I'll teach you what odds are, but they're not the same as probability. I'm not going to answer that question. The probability is, Mike already said it while you guys were all being weirdos. The probability of something happening is just a measure of how likely it is to happen. That's it, bottom line. So it's probability is a measure, and it only exists on a spectrum between two numbers. It's interesting that we're going to spend 3 at least weeks of class talking about math where every answer is somewhere in between 0 and 1. I know, right? And so I know Micah's looking at me like I'm crazy because he's like, wait, I thought it was 100. That's if we're talking in terms of percents. And so if we did our probability spectrum on percentages, then it would go from 0% probability to 100%. Say again, I couldn't. We are doing fractions, yes. So we're going to be on fraction mode here for a while, okay? And there will be times when the percentages are going to be okay, but generally the fractions are going to be what we go to. So when we talk about the probability spectrum, it goes only from 0 to 1. Every answer in probability exists in between these two numbers. And so there are the two boundary points, and then we'll get to like, how do you actually do it? It's very easy. If something has a probability of 0, what do we say about it? It's not going to happen. And I'm not talking about like it's probably not going to happen. Like people say, oh, you mean like a meteor falling out of the sky and hitting me on the head when I'm walking in my car? That's not 0. I hate to break it to you, but it could happen. Is it really, really low? Yeah. It's probably like 0.000001 or like 1 in 500 billion or something. Like it's probably not going to happen, but it isn't impossible. So if something has a probability of 0, it is literally impossible.
That's like saying a shark attack.
A shark attack is not impossible. Like
it's not impossible.
Things that people sometimes say are impossible are often, if you think about it, actually just very unlikely. Here's an example of something impossible. If I took a die, a 6-sided die that had the numbers like the kind of die that you play a dice game like Yahtzee with. If I took one of those 6-sided dice and I rolled it, what's the probability that it will show me the number 7? It's 0. That one I can say is 0 because that one's not up for like silly debate or discussion. It literally cannot produce the number 7, correct? Okay, so that's what we mean when we're on that far left end of the spectrum. We say something is impossible, not unlikely, impossible. On the other end of things, what does a probability of full 1 mean?
It's going to happen.
It is 100% going to happen. It is guaranteed. And an example of that, and I'm going to go back to something again, you might say that the sun will come up tomorrow. I'm sorry to be this way, but it's not true. Something catastrophic could happen. I don't know, but I mean, nothing is guaranteed when we think in terms like that. It's very, very likely that the sun will rise again tomorrow. It'll, rise in the east and set in the west, just like it does every day. But an example of something that's guaranteed is this. If I grab that same 6-sided die and I roll it, what's the probability that I'll get a number less than 7? It's guaranteed. I'm either going to get a 1, a 2, a 3, a 4, a 5, or a 6, and all of those are less than 7. So when we hit the boundaries of 0 and 1, we're not kind of mooking around with like pretty much not going to happen and pretty much going to happen. These are guarantees, either not gonna or has to. Clear? Now, as we slide around on the spectrum in between, so here's like a yellow dot. If I make a yellow dot right about here on the spectrum, what would you say is the probability of that? You don't have to give me a math answer, just like what would you describe it as? You don't have to give me a number. It's a pretty slim chance, right? It would be like if I reached into a deck of cards, a 52 card deck of cards, and I said, what's the probability that I'll pull out a 4? It's not terrible. I mean, there's 4 of them out of 52 cards, right? So it's very unlikely, slim chance, but it still could happen. It's not unreasonable to consider. If I moved my yellow dot over to here, what do we say now? This is where people often use the term 50-50. So that if we were talking percentages, you say it has a 50% chance of happening. In a fraction, what would it be? It would be 1/2, right? And if it were a decimal, then it would be 0.5. That's something where we say it's right smack in the middle. And an example of this is if Haley flips a coin. What is the probability that it lands on heads? 1/2, 50%, 0.5. Okay. And then if we move the yellow dot, of course, closer to the right over here, what are we saying now about the probability? It's a pretty good chance, right? And an example of that would be that if I were right now to draw a name of people not named Mr. Ahern in this class, what's the probability that I would randomly draw the name of a female? And I say that because there are 5 females. There are 5 females, aren't there? So if I put 7, your 7 names in a hat, 5 of them would be females and 2 of them would be males. So if I reach in blindly and grab one, it's a higher likelihood that it's going to say Aubrey, Shariah, Peyton, Haley, or Miss Orozco, correct? So y'all clear on how the spectrum works? The 0 is literally impossible. The 1 is guaranteed. And as the dot slides from left to right, things become more likely. Okay, good. So let's talk about how do we actually construct probability. So let's consider that we're going to roll a die. And just so you know, so that we don't get in arguments with each other over the next few days, the die, D-I-E, is the singular term for dice. So if you're playing with more than one, like playing Yahtzee, you say, oh, I use 5 dice. But if you just grab one and roll it, it's like a 20-sided die, D-I-E. Okay, so I don't want you to think like I'm losing my marbles here. Did you know that already? Some people don't know that. So singular is a die. So if I roll a die, and please assume for the sake of kind of normalcy that if I forget to mention, I'm usually talking about a 6-sided die. And again, that's just the standard kind that you would play Yahtzee with. So if Peyton were to grab a die and just roll a standard 6-sided die, why are you glaring at me like that, Peyton?
So first time someone told me, I thought they said go roll and die.
So if Peyton were to grab a 6-sided die and roll it down on the table, what is the probability that she would roll a 4? Now we are going to do fractions. Micah asked about this earlier. Okay, we're not going to do percentages. We're going to do fractions. So does anyone know how to actually build a probability?
Or how many numbers? 6, so don't you take
First off, Shariah says something real smart here. Let's think about this. How many things can happen when you roll a die? That goes on the bottom. So boom, poof, there you got the bottom of your probability fraction. How many of those things are named 4?
1.
Done. So we say the probability of rolling a 4 is exactly 1/6. Okay, let's change it up a little bit. Let's say, what's the probability that we roll an odd number? Listen, the first part of this conversation doesn't change. How many things can happen when you roll a die? That goes on the bottom. There are 3 of the outcomes on a die, 1, 3, and 5 that are odd. So you put 3 out of 6, and you always reduce your fractions. Stop saying 50-50, please. What is this? What is the probability as a fraction? It is 1/2. 50-50 is fine for like daily casual conversation, but if we're going to get through this unit, we have to think in terms of 4/7.
Yeah, but if you're looking, I was thinking fraction.
Well, then I don't think you're going to do very well on this next test.
I want to work real hard.
I'm sure you're going to do just fine. Just make sure you convince yourself, please, I got to use fractions. When building a probability, you put the bottom number first based on how many things can happen, and then you put the top number. Good. All right, let's do a deck of cards. So when we talk about a deck of cards, we're going to talk about a standard 52 card deck. So sorry, I'm not ready for these numbers yet. I don't know what all that tapping is, but you just have to stop. You're going to drive me nuts. You know, Dalton, I think that's you over there, buddy. So let's say we grab in a deck of cards. Okay, so a standard 52 card deck. I'm amazed at how many kids don't play cards. Like I grew up playing cards. Rummy,
Why do you not play?
cribbage. Some people just go, I never play cards. I go, how do you get out? How do you get out of teenage kid years without playing cards with your mom and your grandma? Yeah, cards, man. So you should all kind of know the structure. If you don't, you're going to learn it real quick. The structure of a deck of cards is that there are 52 cards. There are 4 what we call suits. They're called diamonds, clubs, hearts, and spades. And each suit contains 13 cards. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. So 13 times 4 is a 52 card deck.
Okay.
So I would say if I reached into a deck just blindly, if I just shuffled the cards around on the table, what is the probability if I reached into a deck that I would pick the 5 of hearts? Yes. And again, the way I'm going to build probability is never going to change. We're going to be doing a lot of this, and I'm not going to like veer off course. The bottom of my probability is I say, how many things could happen? Well, I could grab any one of 52 cards, right? How many of them are named 5 of hearts? Of 1 out of 52. So far, so good? Okay, let's go in and let's reach into that, put that 5 of hearts back in, and let's reach back into that deck. And let's say, what's the probability that we grab a red card?
Just a red card.
Just a red card.
That's it.
Yeah, I mean, there's a lot of ways to think about this. And yes, Micah, I'm going to arrive at your conclusion soon. But for someone who's maybe not comfortable with a deck of cards, eventually you figure out that, okay, I got this. There's 52 cards in the deck, right? And you guys probably know that the hearts are red cards and that the diamonds are red cards, right?
There's 2 of each. Right?
And there's, how many are there? There's 13 of each.
Yeah.
So if you take 13 hearts and 13 diamonds and add them together, you realize that 26 of the cards in your deck are red. And then you say 26 out of 52 reduces to 1/2. And then you go back and you think about a deck of cards and you say to yourself, wait a second. There's 4 kinds of cards. There's clubs. Sorry. Spades. Did I offend you by not, did I like ignore you?
Yeah.
I'm really sorry. I hope
No,
we're going to be okay.
Yeah.
I'm going to make it.
Yeah.
So we have clubs, spades, hearts, and diamonds. Think about it. Those are the 4 suits. And the clubs and the spades are black, but the hearts are all red and the diamonds are all red. So if you don't want to make a big math problem out of it, just think smart and say, well, gosh, half the cards are red and half the cards are black. So the probability of pulling a red card is obviously a half, if you don't want to make a big deal out of it. How about this one? Still got to move this stuff down. Almost ready for that stuff. What's the probability that you will pull a jack?
There's 4 of them.
There are 4 of them. That's a great place for us to start. So let's begin with the bottom. How many cards are in the deck? 52. How many of them are named Jack?
4.
And again, you'll come to recognize some fractions. You use the same fractions sometimes over and over again, and you're like, oh, I just know what this is. It's 1/13. If I divide the top and the bottom both by 4, I realize that exactly 1/13 of the cards are jacks. Jack of hearts, jack of diamonds, jack of spades, jack of clubs. Good so far? Okay. I'm actually just going to make a new page because I'm still not ready for those numbers just yet. So here's a spinner. And that's supposed to be a circle. So if you don't think it's a circle, well, no, we're not going to play roulette, but we will. It's not actually play, but I mean, we'll talk about a roulette wheel.
Or pizza.
Our probability stuff will get very complex at some point. Problems that if I were to ask them today, you'd be like, what are you talking about? But there comes a point where, again, if you're here and staying caught up, you'll be amazed at what you're capable of figuring out. So here's the spinner, and we're going to put A, B, C, D, E, F, G, and H. So you can picture, this is one of those spinners that has like the little flicky wheel. I'm not going to draw the flicky wheel because it just looks like a dumb arrow, but you know, you flick it with your finger and it spins and then it points to something. So right now, if I were to say to you, let's just run through a battery of questions here. If Micah spins the spinner, whoop, what's the probability that it lands on a B? 1 out of 8. Very good. 1/8. What is the probability, if he spins it, that it lands on a vowel? Starts out as there are 8 spaces. 2 of them are vowels, you know, A and E, and then we reduce that down to 1/4. Got it? What's the probability that we get a letter from the word card? Again, what's the bottom going to be? What's the bottom going to be? The bottom, come hell or high water, is going to be 8, right? There's 8 spaces. Start with that. Now, when I look at the spinner, I go through and I'm going to put a little check mark next to every letter that is contained in the word card. So is A in the word card?
Yes.
Check them off. Is B?
No.
B is not in card. Is C?
Yes.
Is D?
Yes.
Is E?
No. No.
F? G? H? What's the answer?
Yes.
Done. Do all sorts of things with this. Now, there's a harder version of this, and that's what we're going to talk about next. Got it so far? Okay. This is where it'll get a little bit mathy, so sorry. Can't really get away from the math. Micah, don't answer too quickly, okay, please? If you guys were to spin this spinner 40 times, how many times would you expect to get the letter D? Now, if you listen, in a perfect world, what's the probability of getting A? 1/8, right? What's the probability of getting B? 1/8. What's the probability of getting C? What's the probability of getting D? In a perfect world, that's how the data would go. If Aubrey sat there in a perfect world where everything went according to plan and she spun this thing 40 times, she'd spin it and it would land on A. She'd spin it, it would land on B. She'd spin it, she'd land on... When she's done, and again, Micah, I hate to break it to you, but I want someone else to say this out loud. If you spun that thing 40 times and you made like a tally, here, I'll make a tally. I'm going to get rid of these probabilities out here. Let's say every time you spun one, you put a little mark next to one of the letters. How many of each would you expect to get? This will be the hardest probably thing, or second hardest thing I ask you to do today. Why would you say 5? Yes. It's exactly simple math. If you have 40 things that you're going to do, and you know that you have to subdivide it by 8 things that are equally likely to happen, then it makes perfect sense to me that when I'm done, there should be 5 of these, 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 and 5 of these. Do you agree with that? Mm-hmm. So in a perfect world, you'd get 5 of each kind. So far, so good? Okay. How about this one? We're going to flip a coin. And we're going to flip it 10,000 times. Got it? In a perfect world, how many heads would it land on?
5,000.
I agree. The perfect breakdown, we talk about perfect world. If we broke it down into heads and tails, exactly 5,000 would be this, and exactly 5,000 would be this. Is that going to happen? God, no. You flip a coin 10 times, I can almost guarantee you're not going to get 5 heads and 5 tails. You're going to get something cockamamie like 7 heads and 3 tails, or 2 heads and 8 tails. What happens, there's something in math called the law of large numbers that says if you do something enough times, it eventually starts to do what it should, right? So this, what we talk about here is like perfect world scenario. How about this one? We're going to roll a die. 120 times. Getting a little tougher now. Are you still with me?
Yes.
Could you please put your phone away? I can't describe to you using any words that won't offend people how much I hate your cell phones. Both Micah and you, Aubrey, back there scrolling on it. I need you to understand what a detriment that is to my cause. So could you please get it off your desk and put it away? Someplace where you literally couldn't use it if you tried. I love my cell phone too, and I wish I could just sit here and play on it, play some like knockoff Candy Crush or watch some brainless TikToks, but thanks. This is a tough one. So let's break. Go ahead.
Okay, so about 6 by, right?
Right.
You're gonna do over 6, obviously.
Let's make a table. How about this? Let's break it down like this. So if we were to make what's called a frequency table, and every time I rolled a die and it landed on one of these outcomes, I would put a little check mark or a tick mark in the appropriate box, right? When all is said and done, how many should I have in each of these? There's a way to figure this out. How many times are you doing the experiment? How many things can happen? What's 120 divided by 6? What's 12 divided by 6? So just add a 0. That means you should get 20 of these, 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 20 of these. You see the flow? Would that happen?
No.
Absolutely, unequivocally, probably not. That would be an example of a really freaky thing. You'd wind up with like 24 of these, 31 of these, 4 of those. I mean, who knows? But that the way things are supposed to work and the way they do work is never the same, almost never. Correct. Yeah, we're going to be asking you about perfect world probabilities. Correct. Yep. Does that make sense?
Yeah.
Don't be scared. Okay, back to these numbers finally, and this will be the last part, and then we'll work for just a little bit here today. So, have you fallen asleep? Do you need 30 seconds to wake back up? Because I can't have you sleep through this part, the worst part. We good? Okay. If I reached in, say I took these numbers as colored and I randomly sprinkled them into like a cookie jar on little Scrabble tiles or something, and I reached in and I grabbed one, what would be the probability that it would be a red or an even? You are 98% likely going to get confused on what I'm about to explain. So I'm going to pour myself some coffee, and I want you just to pause, stretch out. Okay. The word or is confusing because it means that you can be either of those things. So let's go through, and I'm going to teach you the best. If you're willing to come along and be cooperative, this is the best way to do or probabilities like this. First thing we're going to do is we're going to count the reds. And I'm not trying to insult you. I know you can count, but how many reds are there? So we're going to write down 3. And by we, I mean all of us. You should be a part of this. 3. Now, we're going to go through and we're going to count the evens. How many evens are there in my cookie jar? Keep going. There are 6. And I'm going to circle them and then uncircle them. They are here, 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 in here. Those are all even numbers, and there's 6 of them. So far, are you with me?
Yeah.
So you're like, well, this ought to be stupid easy. I don't know what you're dragging on about here, Mr. Math Teacher. Like, get over yourself. So you're like, this answer is really easy, right? Because there's 12 things that I could pull out of the jar, right? And if I'm red or if I'm even, then the answer, I should just be able to add those together, right? There's a problem. Can you tell me something exceptional about the number 2? Oh, it got counted twice, and that's going to be a huge problem. In an OR problem, you don't get to count anybody twice. That number has to decide. Yes, he's having like an identity crisis. He has to either say, I'm red or I'm even, but he doesn't get to factor into both groups. And so here's what you do. You take and you add the 2 together. This red number is 3 and the even number is 6. You add them together. So I'm going to switch colors and do yellow up here in the corner. So you take them, you add them together. Now, how many numbers up on my board met both criteria of being both red and even?
1.
So we take away 1. And what is 3 plus 6?
9.
What is 3 plus 6? 9. And 9 minus 1 is, so the answer is 8 over 12, which we would reduce. Got it? I got you, buddy. You're just too fast. I'm still trying to explain a concept and you're just math, and I'm sorry. I appreciate your eagerness, but got it? So you add and then subtract out the ones that are repeaters, however many there may be. Got that? And yes, Micah, we would reduce this down, divide them both by 4. The answer is 2/3. Let's go again. You reached into the cookie jar and grabbed one out at random. What's the probability that it would be white or odd? There's 2 kinds of people in this world. There are people that straight up learn how to do this, and there are people that will make a mess. Don't race ahead of me, okay? Let's take our time and let's do our process. Count with me. How many tiles are white? So I'm going to write down 7. I should say we. You're a part of this. We're going to write down 7. And then I'm going to put a plus sign because now I need to do the other category. How many of the numbers up here? I don't give a crap about their colors. How many of them are odd? 6. 1, 2, 3, 4, 5, 6. So once again, I'm going to have a basic addition problem, and I'm going to say, okay, so 7 of you were white, 6 of you were odd, but now there's going to come some subtraction for the ones that got double counted. Can you identify the ones on the board that got double counted? 5 got double counted. Aubrey, I'm with you on this one. How did 5 get double counted? Is he white? Yes. Is he odd? Yes. So he factored into both, which is why we have to take him out. He can only be counted once. Who else got counted twice? So did 7. And so did 9. So how many repeaters did we have? So we go 7 plus 6 minus the repeaters. What's 7 plus 6?
13.
What's 13 minus 3? So the answer is 10 out of 12. Got it? And yes, we reduce. What does that reduce down to? There you go. Got it? Last little bit of this is I'm going to change the word or to the word and. Got it? And it's going to make a huge difference. And so when I change the word or into the word and, the way we behave, like the way we think about this, is completely different. So here we go. Let's do the probability of white and odd. So for your notes, I know it looks like a little thing, but pay close mind to the fact that we have changed now. I'm no longer giving you options. I'm not saying you could be this or you could be this. I'm saying to be in the cool kid club now, to make it into the top of my probability fraction, you have to meet both criteria. These problems, a million times out of a million, should be simpler. These are so easy if you're willing to see it for what it is. How many numbers on the board could you say are white and odd?
Sorry.
White and odd. Okay, this isn't going well. Let me ask you a question.
5, 7, and
Is
9.
this number that I'm going to use yellow now, is that number white and odd? It is not white, it's
not
red. So 3 is not in the club.
So it's 5.
You have to be white and red. So 3 is not in.
I'm colorblind.
11 and 12 are purple.
It's 3 because it's 5, 7, and 9.
Yes. So to be white and odd, you have to be this guy. Is that guy white?
Yes.
Is he odd?
Yes.
He's in. How about this guy?
Yes.
White and odd. And this guy?
Yes.
Piece of cake. So my answer is out of 12, there are 3 of you. You reduce to 1/4. So, and both things have to be true, or either one of them can be true, but you have to subtract out the ones that get repeated. You think you got it?
I can't that.
I'm going to give you the first couple of worksheets today for Diedrich and Trinity and Aiden. I'll just post these and they'll have to do them on separate paper. But you guys will get paper copies. They'll do them on their own. So you guys going to have questions. You're going to have questions. And when you do, just ask. All right? I'm going to leave the recording going. I'm just going to pause it so that if you guys have questions and I feel like, ooh, I wish that the 3 that were absent knew this, then I'll unpause it for them. So